Okay, continuing on our discussion of synthesis, we talked about in the block diagram for how we think about sound in a synthesis construct. We have our carrier signal, which is the horizontal path from the oscillator. We could start with a sine wave oscillator. We can specify a particular frequency for the oscillator, let's say 500 hertz on this one. Going into some kind of filter, which is the square tells us the filter. If you see something that is a VCF, you know that it's going to be a voltage control filter. Over here we have the VCO, and then a VCA, voltage controlled amplifier. And then in order to determine what kind of filter, we would see something LPF, which tells us that it's a low pass filter. Then you would have to have some kind of cutoff frequency variable on that into our VCA. But I mentioned there are other kinds of ways we can affect the sound in the synthesis through other kinds of sound processing modules. One that's very common would be a envelope generator. An envelope generator, which I'll describe, let's say if we plug an envelope generator into our amplifier. And the envelope generator usually is a rectangular device, and we will have 4 knobs on a classic envelope generator, and often this is abbreviated as an EG. Each knob has a different function. The first knob will control the attack. In order to understand how this is a time variant DC current in the classic analog synthesizers. So it's not an alternating current, it's a DC current, which is a direct current. And this is a particular type of direct current called time variant, which the envelope generator creates. So in order to understand that, let's put it a little bit of a time scale to understand, and then our time is going this way, and then amplitude this way. So if we were to draw a symbol for how we would set the attack, decay, sustain, and release, so that's what these 4 controls are. The first, well, actually the attack, decay, and release all are rate controls. The sustain is a level control, and that's the one difference. So when we have a envelope generator plugged into our VCA, what's happening is the signal coming through here is being set up at a particular volume, a particular amplitude, so that when we set our attack, let's say we set the knob, the potentiometer, to a little bit of attack, which means it's a rate control. It takes a little bit of time to rise to the maximum amplitude that the VCA is creating, so that the amount of time from silence up to that amplitude is determined by the attack, or the amount of time it takes to attack to that level. If you have a secondary sustain level, and that's why the sustain is a secondary level. So if we have a sustain that is set at a certain point, then once we get to that maximum amplitude here, then we have a decay time that would get us to a secondary sustain level. And you would stay at that level indefinitely, so that the attack is a rate of how much time it takes to get to the maximum amplitude. Then the decay is the amount of time it takes to go from that amplitude to a secondary sustain level, which is set by our sustain knob. And then you would stay at that level until you release the sound, till you stop the sound, and then we have another release rate, which takes us back to silence. So the sustain is a level setting, but then we have 3 rates. The attack gets us up to the maximum, then the decay time is how much time it takes to go down to the sustain level, and then the release is how much time it takes to go back to silence. In this case, we're controlling the amplitude. So this is a time variant envelope generator. And that way we can shape the sound with a little bit more interest than just kind of a flat sound. So if I come back over here to my Reason analog synthesizer, remember we've got this, and I've got a triangle waveform pulled up just for a second. It could be any waveform, doesn't really matter. I've got my filter all the way up here, so I'm not really filtering anything. But we look right here where it says amp envelope. And this is that envelope generator that is plugged into the amplifier. And you see the ADSR configuration. So if right now I'm triggering the note and you hear an immediate attack. If I take my decay here and my sustain level all the way to top, you see there is no secondary sustain level. It's still going through an envelope generator path, but there is no time for attack, so it's an immediate attack. there is no time for decay, and my sustain level is at maximum, so I don't really hear any change of level because the sustain level is there. And then my release, when I release the note, you can hear a slight amount of time it takes to get back to silence. If I increase this, then the sound takes more time. It's a smoother rolling off of amplitude back to silence. If I take it here, then it's an immediate drop off, which usually, acoustically, we don't hear sounds that are that sudden in nature, because usually there's some resonance of sound that reverberates around the room naturally. So when you hear a saxophone or a cello stop vibrating, we hear a little bit of time where the sound bounces around the room, and that sounds more natural to us before the sound finally decays. If you're in a very live space, the sound may not decay for a long time. So I hold that and release, and then it's a very long decay where the time it takes to go to silence takes a long time. But that's more unnatural. So then the same thing, if I go back to my attack and I change that rate, you see it does not attack immediately. I can delay, so a very soft attack. Now, let me take my sustain level down so you can hear a change here. And what we'll have is we'll have a long attack and then no time to get to that secondary sustain level. So you hear the slow attack to its maximum amplitude, and then it took no time to go back to this secondary sustain level. So it immediately drops in volume because the decay is at 0. If I move my decay time up, then you hear it rise up slowly, and then it will slowly go back down to the secondary sustain level. It'll sustain at that level until I release the key now, and then it goes to its release rate. If I have my release up, I have a slow attack, a slow decay, a medium sustain, and then on a release, it slowly goes back to 0. So that way I have 4 different control parameters that I can shape the sound to whatever I want. You know, when you think about acoustic instruments, and here again, synthesis is trying to give us not only the ability to replicate acoustic instruments, but to make other sounds that we can't find in traditional instruments. But example, like a piano. When you play a piano, think about this for a second. A piano makes its sound. When you play a note on the piano, you've got a hammer inside the piano that strikes a string and starts it to vibrate. That percussive effect means that if you were trying to replicate a piano, you would have to have your envelope generator with a very short attack, because there is no way to have a slow attack on a piano. But if I have a violin or cello, I could start bowing the string very slowly and slowly move into a loud amplitude. So I could actually have a longer time to reach the full amplitude on a violin, or any wind instrument has that capability. So the difference between percussion instruments and wind or strings has to do with the ability to shape the attack of as we call the articulation point. Also, on a piano, you would not have any kind of secondary control over sustain. So once you get the attack on the string, you're in a constant state of decay on a piano going back. So you would have to get rid of your sustain level and then have just a very long release point of some type. So that's why each instrument, you would have a different kind of way of shaping that sound with your envelope generator. So the envelope generator obviously is a very important modifying device that gives us some ability to shape the sound around something that's more interesting to us. And we can have envelope generators can be plugged into each of these devices, and we'll talk about how that functions in just a second. So the envelope generator is maybe the third most important component that will be found in our synthesis patch.
The preceding program is copyrighted by Emory University.